So now we're going to look at the fundamental theorem of calculus. The fundamental theorem of calculus says that if you have a continuous graph on an interval AB, and there is an antiderivative, which they refer to as capital F of x, of the original function, then we can find the definite integral from a to b of the f of x being the antiderivative plugged in with b minus the antiderivative with a plugged in. A couple of things about notation. There's kind of an in-between step. This little guy right here. The capital F of x with a line AB means that the antiderivative that's evaluated from b to a, b minus your a when you plug it in. So if we look at this particular example, we can see that it goes from 3 to 7, so we want the area under the curve between the x values of 3 and 7 of your x squared. So your in-between step is basically taking the antiderivative of x squared. Now if you remember, when you have a power of something to a power of n, you always go up a degree and then you divide by your n plus 1, which is 3. Now this is then evaluated from 3 to 7. So that is why we have this little in-between notation. We take the antiderivative in the general term in terms of x, and then we write down what we're going to evaluate it between. Then you can say that it's going to be f of b minus your f of a, capital F, capital A, capital F of a. Then we have 7 cubed all over 3 minus 3 cubed all over 3. So then we can write that the integral from 3 to 7 of x squared dx is going to equal, now 7 cubed is 343 all over 3 minus 27 all over 3. So the area under that curve is 316 over 3. So it's a definite integral. It's the area under the curve of x squared between 3 and 7. Now just a reminder as well, you do need to know these basic antiderivative formulas that we talked about from the last unit, the last section, where you had your power rule, where you go up by a power and divide by n plus 1 plus c. And then we also have your sine and your cosine ones that you need to know. The other ones for secant and cosecant and cotangent and tangent also will be given to you, usually in the cheat sheet at the top. So we find the area under the curve of g of x over 2 to 5. Now in this one here, they actually give it to you in a word statement. They don't actually set it up for you, so you do need to know how to set this up as well. When we're taking the area under the curve, we're going to take the integral of your g of x from 2 to 5. That's your interval range. And again, we're going to use our power rule and the fact that you can add the two parts and you bring your constant up front. So this is then the same as saying 3 going up a degree dividing by 3 plus 2 going up a degree dividing by 2 minus your 1 and going up a degree and dividing by 1. This is then evaluated from 2 to 5. So that's your antiderivative, which will be evaluated from 2 to 5. Then you would then plug in the first one, 5 cubed over 3 plus 2, 5 squared over 2, minus 5. So that's your f of b minus, now your f of a, we plug in 2. And granted, things do cancel out in this. I'm just filling it in just so you can see where I'm plugging everything in. So there's your f of b when you plug in 5. 5, 5, 5. Here we plugged in 2, 2, and 2. So I filled in all the work. As you can see, I've kept everything in terms of my f of b in one square bracket here, and then one over here for f of a, then subtracted the 2, and I get 135. So now in this particular case, I'm looking again for the area under the curve between x being negative 1 and 1 of this function here, so a quartic. So again, we're going to use the same power rules. The only difference now is that we have some x values that are negative, but that doesn't change anything. Ultimately, we're still going to do f of b minus f of a when we get our antiderivatives. So if you go ahead and you take the antiderivative of each of these, you're going to go up by a degree, so x to the fifth all over 5, plus, and in this case here, x cubed over 3 minus x squared over 2, evaluated from -1 to 1. So versus what we were doing before when we had the indefinite, we had plus c at the end. Now we have to actually take the antiderivative and make sure we have the proper notation so we know what we're evaluating it over. And again, f of b, so we would, again, things do cancel out, but we would plug in our b value, which is 1. So you'd have 1 to the fifth all over 5 plus 1 to the 3 all over 3 minus 1 squared all over 2. That's our f of b, subtracting, and then we plug in our -1 in this case, so -1 to the fifth over 5 plus -1 to the 3 over 3 minus -1 squared over 2, and that's our f of a. So as you can see, then when we cross out everything and simplify, we get down to the integral from -1 to 1 of their function is going to be 3 and 5/6.